So next we're going to hear about how Petronas has used project production control implementation to improve a construction schedule performance. We have 4 very experienced speakers here, and I don't want to rob any more of your time giving your lengthy introductions. So I'm going to give a really brief introduction. Your bios are all on the website. Just to take it from me, these are very experienced folks. They know what they're talking about. They've got some good firsthand experience. So first off, we have Hakeem Matazir. Hakeem, where you raise your hand? Okay, there you are. He's currently an analyst with project delivery and technology sector of Petronas. We have Hafiz Izar. There we go. Hafiz is currently assigned to the Kashiwari gas development project as a structural engineer. We have Hamida Makmour Bakre. Raise your hand. There we go. She is a senior construction engineer. And we have Irwan Shafizad Hazidan. Irwan is currently assigned as a Kashiwari gas development project as a senior project planner. So we have all facets of the project represented. Share your presentation and I'll turn it over to you so we can use our time effectively.
Thank you, Gary. So good morning to all. Today, our team would like to present and share our technical paper entitled Project Production Control Implementation to Improve the Construction Schedule. So these are our presentation outline, which consists of 7 parts. So I will be explaining the first 3, and my colleagues will explain the rest of the parts. So next, I will touch a little bit on the abstract. For this paper, it's actually demonstrate the effective application of project production management methodology to positively impact construction progress and increase productivity, while exposing sources of detrimental variability as the focus of continuous improvement practices, and at the same time sharing of lesson learned and best practices to PPM practitioners across the globe. So for this PPM implementation, for this specific case, our buoyancy tank has been identified as the critical path that drives the overall CPP Jacket construction schedule. So PPM supports this finding by exposing the high capacity demand during the fabrication process. During the construction of the buoyancy tanks, the demand and duration of the fabrication was underestimated due to its design complexity, and PPM methodology is adopted as an additional measure to complete the scope timely. So before we move on further in this presentation, I would like to share a success story following our CPP Jacket installation. So allow me to play these 2 videos. These 2 videos showing the comparison between our design simulation and our jacket launching in the actual site. So as you can see, this show how important and significant the buoyancy tank is, because in order for us to float the 18,000 metric ton jacket, we need that buoyancy tank, and it's to ensure that the operation is safe and smooth. Okay. So I will touch a little bit on this, our project overview, and also the brief CPP Jacket overview. So this jacket is an 8-legged jacket at a water depth of 108 meters. So it has 12 skirt piles with penetration of 102 meters below mud line. And the weight of the jacket is quite huge, which is about 18,500 metric ton. And the jacket is having 7 numbers of buoyancy tanks. And the weight of buoyancy tank varies. So as you can see here, BT1 and BT2 are about 435 metric ton each. BT3, BT4 are about 191 metric ton. BT5, BT6, 231 metric ton. And last, the BT7 is about 261 metric ton. So as you can see at the picture below, this buoyancy tank was heavily strengthened by the T-ring and angle bar at its 16 mm shell to cater for the hydrostatic collapse during the launching operation. So each buoyancy tank will have 2 to 3 numbers of internal flooding compartments for the jacket set down process. So this picture shows how massive is the buoyancy tank compared to normal size man. And next slide is, this slide is showing our buoyancy tank fabrication assembly and erection at our contractor's fabrication yard. And it also shows that how massive and complex the buoyancy tank is during the fabrication and also the assembly. So that's all from my part. So for the next part, I would like to invite my colleague Puan Hamidah to continue this presentation.
Thank you, Hafiz. Good morning, everyone. Now I would like to explain on how did the comprehensive design of the buoyancy tank has impact construction activities. So due to the design complexity of the buoyancy tank, we have identified three major impacts to the construction. The first one is the construction schedule itself. The second one is the increased number of the resources required. The resources were segregated into few categories. However, for this sharing, we have selected three types of resources, which is the manpower, equipment, and the materials. And the third one is the major fabrication and erection sequence changes. Okay, so let's see the first one. This is the evolution of construction schedule impact from revision 1 to revision 2 for the buoyancy tank construction. As you can see, the construction schedule was revised to revision 1 in Q1 2020 due to the duration of the buoyancy tank construction were underestimated. In Q1 2021, PPM was then implemented and parallel exercise of revising construction schedule and PPM input, and the master schedule was then revised to revision 2 in Q1 2022. As you can see, the schedule is moving to the right and required more days to complete the fabrication works. Now we move to the details of the impact to the resources. The first one is the manpower. Based on the master schedule revision 2, the cumulative numbers of man hours specifically for construction duration for the buoyancy tank has increased about 20% from the plan versus actual. And this increment is due to the complexity of the design, which required more manpower and man hours to cater the fabrication activities. So the second one is the number. In equipment loading, increased number in equipment loading. For example, the crane usage, which the initial plan is to utilize two numbers of 600 metric ton crane. However, due to the size and the weight of the buoyancy tank itself, the crane capacity has to be changed to two numbers of crane, which increase the capacity of the crane to 400 metric ton and 1,200 metric ton to cater the lifting and the erection activities. And the last one under resources is the additional material that required in order to support the complexity of the design. Based on record, the variance of 1,074 metric ton was recorded as the additional material required as compared to the fit design, which is supposed to be 900 metric ton for only two numbers of buoyancy tank. However, the actual is 7 numbers of buoyancy tank with total of weight of 1,974 metric ton for all the 7 numbers. The last one is the fabrication erection sequence impact to the project. As you can see, on the left-hand side is the planned erection sequence versus the actual erection sequence on the right-hand side. The planned erection sequence is supposed to be from buoyancy tank number 1, 2, 3, 4, 5, and 7, 6 and 7 accordingly. However, the actual one, the number has jumbled and it goes to 1, 2, 4, 7, 5, 3, and 6. However, the actual sequence has been rearranged to cater the design complexity and to expedite the construction progress. So, the construction industry is a complex and dynamic field that requires effective management strategy to ensure the successful project delivery. And one such strategy is the project production control, which views and manages a project as a production system or the collection of production system comprising the interconnected network of processes and operation that represent all the activities to execute a project from start to finish. And for this specific sharing, the comprehensive design of the buoyancy tank has led to the extended duration of fabrication and significantly has increased the resources requirements such as manpower, equipment, and material. It has also affected the current fabrication sequence and ultimately the construction schedule. I think next I would like to call upon my colleague, Mr. Hakim, maybe to explain on detail how is the PPM has been implemented to accelerate the construction progress. Over to you, Hakim.
Thank you, Hamidah. Now, let us move to the PPM methodologies. As we may already know, it comprises of three main steps, which are step 1, map and model, in which the creation of task digital twin of the construction process and defining the production steps and systems required to produce the asset. Step 2, simulate, analyze, and optimize based on the operation science to get the maximum throughput, control the work in process and to improve the cycle time and get the work done faster. So we plan and control the sequence of work at the execution level and learn how to do more with limited resources and eliminate the source of variabilities. Step 3, control and improve, conduct the daily production planning and enabling the production analytics to be unlocked and utilized by the project team. Moving into map and model. During the PPM deployment, the team undertook an analysis on the CPP Jacket overall production system, which include the mapping and modeling of the individual component fabrication and its erection sequence, and the final product is as shown in the figure. So this effort has identified the subcomponent of the production fabrication that would produce the most significant demand on the limited capacity, which is during the peak period, which in this case was the buoyancy tank as highlighted in red. Now, by the completion of this exercise, the team had already understood the 5 levers of the production management and how it can be utilized to complete and accelerate the project. So the product design, which was described by Hafiz, the extraordinarily complex engineering design of the CPP Jacket and buoyancy tank. Then the process design, which is the fabrication and the erection sequence of the construction work that is required to complete the project. The capacity, how the resources required to build the CPP Jacket will be acquired and allocated, including the contributors such as the equipment, tooling, labor, and space. The inventory, how we want to control the work in process, queue, and stock, and the location required to build the CPP Jacket, which to be determined and controlled. And last but not least, the variability, how variability will be managed and is the project able to absorb. Now, after the completion of the map and model, we move to step 2, which is the simulate, analyze, and optimize process. Primary findings by PMT that indicated the construction schedule will face constraints to meet the desired completion milestone. PSO analysis further strengthened these findings. So by doing the PSO production modeling, it's highlighted the resources required were overloaded for the jacket fabrication. So the analysis provided the breakdown of which components and also which capacity that is bottleneck for the jacket. So on the left, you can see that the forecast of completion by PSO in October 2021, it was predicted 97 days of potential delay against the planned revision 1. It was supposed to be completed by 31st May 2022. Instead, PSO analysis predicted it to be completed by 5th of September 2022. As highlighted earlier, project already made concurrent effort to continue the project and together enforcing a systematic project production control framework. Right. So to begin with, it is important to note that the implementation of PPC requires the owner, which is Petronas, to go beyond the traditional transaction boundaries with the contractor, right, by being more involved in the work. Despite not being an contractual obligation for contractors to provide the daily production planning and updates, a collaborative effort between owner and contractor to understand the production system has proven to be effective. So the shift toward openness and transparency has yielded a positive result in completing the project ahead of time. So it is important to note that the objective of both contractors and owners are aligned, which is to deliver the project ahead of its time. So interestingly, based on the prediction in October 2021 against the actual completion date, the difference is only 5 days. It's only 5 days, which is translated to 95% accuracy. So the CPP Jacket was finally completed on 31st August 2022. Therefore, the full potential benefit of implementing PPC encourage owner and contractors to work together toward achieving the project success. So to describe further, I will pass the session to Erwan to continue with the sharing on step 3, control and improve, and further into its application. Over to you, Erwan.
Hello, hi. Good morning. This is a PPM Insight Analytics. So this is an overview of PPC framework to plan and control daily production at site. So think it's a familiar diagram here. Master schedule is established earlier in the project to define the whole duration from the project start until the completion of the work. For our PVC implementation, we have production schedule and production planning. We need to define our work as distinct as possible in the production planning. And based on the work soundness or the term work front that we normally use in the fabrication that we have at site, we have considered these activities in our production planning. And then we decide what will be executed, committed for the next reporting period, which in this case is the next day. Production plan is then updated based on the daily actual completion activities. And from the progress input, we can determine what improvement that we can execute daily based on the analysis and insights that's generated from the data that we collect every day, and complete the cycle of plan, do, check, and act. So this is how we get closer to the work and also capture the variabilities, showing our actual features at site. During implementation, everybody is involved with the ongoing works. Picture number 1 is showing what we call normally called war room, effectively the daily production planning session, which we held every day, every end of working day to create the next production plan. Number 2 is from the plan that we established to commit for the next day, it is collected and updated in a systematic and structured way. And every worker involved in the fabrication activities will have access to this plan to ensure alignment with all relevant parties and stakeholders. Number 3 is just showing the actual fabrication activities at workshop. And number 4, from the actual progress, we then verify against what we committed in previous reporting day to update the production plan and plan for the next day. This cycle continues daily with everybody's end in mind is to meet the LRM or last responsible moment dates. By implementing PPM at our project, we are able to control and improve especially the short-term work execution, because it enables us to make decisions constantly, especially with analysis backed by actual data. We have, like example here, we have 5 performance indicators that we refer to. Number 1 is the reasons for non-completion, which in my previous experience, normal hiccups or work stoppages that are not properly recorded, especially when it happens daily for analysis, which it may potentially and eventually accumulate to give significant impacts to the overall schedule without being noticed. The next one is the commitment reliability, another indicator that is measuring our reliability of work committed and relate to the source of variability. Task counts. This is simple but powerful visualization of the number of tasks to be executed every day, which at best, of course, in a utopian world, it should be leveled. However, in real fabrication activity sequence, it has limits. The 4th one is the master forecast. With this indicator tracked daily, everybody is aware of the movement of the completion milestone with its trending for overall and also each buoyancy tank. So we know where we are in meeting our milestone. The next one is the look ahead reliability. We utilize this to track our reliability to forecast, especially again for short term. Whether this current setup, we can do good reliable forecast or not, which is very, very important for the team and to report to other management and as well as other stakeholders. So these are some of the indicators that we utilize with daily frequency for us to analyze and adjust as required to meet our target date. So here we would like to share some value creation that we recorded in our project. We started as a pilot in our company with this scale of PPM implementation, but we managed to create value creation from it. With the implementation, we got an increase in productivity and we had better predictability, which is important, as everybody is aware that surprises, variabilities is not what we desired in the project. We recorded 5% cost improvement, which was from the construction alone. And we formulated the calculation of cost improvement, as you can see in the formula there. And based on our actual implementation, we know that PPM is feasible to be utilized for our offshore platform fabrication activities at Fabrication Yard. So this gives credits for PPM to be replicated in another project in our company, which is currently ongoing. And it's already been implemented in another project with quite similar scale of what we have done. This Gantt chart is just visualizing the actual completion date for each buoyancy tank against the planned completion date. We have seen in the previous slide that BT7 is the most complex as compared to the other BT. That's why the completion date is the last one. So the duration variance of each buoyancy tank is what we refer to when we calculate the cost improvement for the resources. Just to conclude our sharing here, we have shown that by changing our view perspective from conventional to production system, it can enhance the efficiency, productivity, and importantly, the predictability. We demonstrated that PSO and PPC method can be utilized for planning and control at our project, enabling us to identify and record detrimental variabilities for analysis in order for us to improve. So these findings supplement conventional project management and have important and significant contribution to our construction planning and control. So this highlights the need and importance for a shift from current approach for construction project management to production system to improve outcomes and success in large scale project, which is for our case the success that we define is the timely completion of buoyancy tank to enable the launch of CPP Jacket at Offshore within the target window as per the first video that we showed before this. So that will be our end of presentation. So we pass to Gary.
Excellent. And that's some pretty impressive results. Great example of the power of predictability through production modeling and optimization, using those 5 levers, and then putting the project under control. So you know where you are, you're making real-time adjustments so you stay on track. Excellent work. So one quick question for you in the few minutes that we have here. What did you see? You mentioned a little bit of it. I want to reinforce it. What did you see using production control that you weren't seeing with traditional project controls?
Yeah, so maybe I will try to take that one before I allow everyone to also say it from the planning perspective, right? So from my perspective, the difference between what we are currently doing, right? So at the owner side, we don't typically go beyond the what we call that somehow the definite what we call it the definite line between the owner and contractor, right? So we tend to only depends on the contractor reporting and also what update were given to us, right? So by deployment of the systematic PPC framework to this project, the owner, whether you like it or not, you need to get closer to the work, right? So you need to get to the ground, get to the floor and understand what is currently the work being done at site and what is actually the variabilities that is affecting the work, right? So without you crossing the boundaries between the contractor and owner and without PPC, you won't be able to get this analysis.
Oh, can I ask you to stop sharing your screen? I forgot to do that so we can see your faces a little more clearly. There we go. Perfect. Okay. So the rest of you want to add anything to that? That was a great answer. Guess not. Okay, we got another question for you. Once you modeled the production system for the tanks, did you redesign it in any way? Add more resources, e.g. cranes and forklifts? Who wants to take that one? Did we lose our connection there? Oh, there we go. Yeah, we're all on mute somehow.
Yeah, so Gary, definitely it will by changing the design, we cannot stop the process of improving, and also the iteration that will be going on the engineering side, like due to the complexity of the work, and also the requirement that like been shared by Hafiz, right? So definitely, when you change the design to be more complex, you will need to add more resources. You will need to get more equipment. You need more time, more man hours need to be spent, right? So, despite this effect, how we want to effectively control and reduce the significant impact to our project, right? So we need to analyze it, find ways how we're going to optimize the processes, identify the production system itself, right? So that we can effectively absorb the changes that being made by the engineering, right? So we are hoping that for the next project that we are doing, some what we call that somehow that we may play with the product design, right? So we get the engineers to be together with us. We discuss together by changing this design, what would be the effect to the production system, which is the process design, how it will affect the sequence of our work that we plan to do, right? So by effectively doing this, we can enable the what we call that the levers, the 5 levers, right? So we can play with the product design, the process design. We can play with the capacity, inventory, and ultimately absorbing the variabilities.
You might have touched on this in your answer there. A great question just came in. Can we bring in production control system and that planning, the production modeling with the project schedule baseline development so that we can improve the planning and avoid efforts later on? So things can be brought closer together. What do you think?
Okay, maybe I will try to answer this one a little bit. I think we refer to our timeline just now from revision 1 to revision 2. We've seen that the implementation of or where the PPM came in is a little bit the baseline development has already passed. But when we do some analytical studies using the PA4 for our CPP jackets, we wish that we could have done it sooner before we develop our baseline development, because some of the input would be very beneficial in order for us to check the baseline schedule that we have and proposed by our contractor is actually doable, or is it too much in terms of underestimate in terms of the duration, which in the end, if we underestimated the duration, like we have seen in the revision from revision 1 to revision 2, then definitely it will cost us in the first opening session just now, it mentions about the importance of delivering our facilities as soon as possible to realize the revenue. So in this case, one day it definitely will cost us millions. Yep.
Yeah, great question. Well, thank you very much for taking the effort to create the paper and the presentation. You all did a wonderful job. And I'll ask you to shut your cameras off now, and we're going to have to move on to our next presentation.